Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we are solving Diddly Maths by Philip Newman. So this is a killer arrow Sudoku. So you have standard Sudoku rules, so we're placing the digits 1 through 9, once each in each row, each column, and each outlined 3x3 region. And then there are also some killer cages in the grid. So in each of these little cages, the digits in the cage have to sum to the clue that's given in the top left corner of the cage. Like these two have to sum to 17, so they are 8 and 9. That's the only way to do that with Sudoku digits. And finally, there are some arrows in the grid. The digit in the circle of an arrow is equal to the sum of the digits along the arrow shaft. And here we have some circles that each have multiple arrows coming out of them. Whenever you see this in an arrow puzzle, each of the arrows sums to the value in the circle independently. So for instance, these 3 digits sum to whatever this is, and then also these 2 digits sum to whatever this is separately. So let's start by filling in some of our easier killer cages. 4 is always 1 plus 3. 3 is always 1 plus 2, because those are very low numbers. There's only one way we can make them, and then the 1-2 pair tells us that that is a 3, and that is a 1. 6 is either 1 and 5, or 2 and 4. 16 is always 7 plus 9. 5 is always either 1 plus 4 or 2 plus 3. 15 is going to be 6 plus 9 or 7 plus 8. And it looks like those are, nope, 14, 5 plus 9, or 6 plus 8. Those are our cages that have only 1 or 2 options, so we can start by filling those out. Now let's consider some of the arrows. So here we have an arrow circle that's either 6, 7, 8, or 9, right? So this digit is on the arrow, so we can't have a 6 with a 9 on its arrow because that's too big. In fact, in general, this can't be an 8 or 9 for several reasons. One of those reasons is that it would be bigger than whatever is in this cell, which would be a problem for having it be part of the sum. Now, if this is an 8, 8 is already only 7 plus 1, so we can't have 8 be 7 plus 1 plus something else. So this must be a 9, making it 6 plus 1 plus 2 to sum to 9. So that resolves that arrow. Now here, we know that 9 has to be 1, 2, 3, or 4 plus something, so we know that's going to be a 5, 6, 7, or 8. Now let's look at our other arrows. So this is a 12 arrow. Or sorry, this is a 12 cage, and it has an arrow circle in it. Now, the only digits in Sudoku that can have a sum of 3 other digits that all see each other are 6, 7, 8, and 9. So we've already used 6 and 9 in the row, so this has to be a 7 or an 8. If this is a 7, then this is a 5. And that would be a pretty big problem, because we would have a 7 there, we'd have a 5 there, and then how do we make a sum of 7? We'd need 2 1s, so that would not work. So we need to have an 8 here, and a 4 here. And the sum that we need here to finish up and make that sum to 8 is going to be 4 more, so that would have to be 1 plus 3. And that tells us that this is either 4, because 3 plus 4 is 7, or 6, because 1 plus 6 is 7. Now 8, there are 3 ways to do it. Either way, we need a lower digit and a higher digit, so we're either going to go 1 plus 7, 2 plus 6, or 3 plus 5. But we've already used the 1 and the 2. I tend to do this when I'm looking at sums along arrows. Look for just low digits that are used or just for high digits that are used. And here I've noticed 2 of my possible low digits have been used. So we must be using our other remaining low digit, which is 3. So that's going to be 3 plus 5. Now the 5 can't go in this cell because that would make this cage 5 plus 5, which would sum to 10, but it would give us 2 5s in the column. So that's going to be a 3. That's now a 5, that's a 7. And we're going to have a 9 here, and a 7 there. So now these are going to be 5, 6, and 8 to finish the row. I'll pencil mark that. That will become relevant a little bit later. Now this cell, it's the bulb of a 3-length arrow, so it has to be 6, 7, 8, or 9, but because we already have a 9 here, it can't be 9. And it's in a 13 cage, so it's either 8 plus 5, 7 plus 6, or 6 plus 7. So it can't be 6 plus 7 because that's far too big to be part of a sum of 7. If it's 7 plus 6, we're already up to 6, and then we would have to have like a 1 and a 0 on this arrow to make it sum to 7. So that's not going to work either. It's got to be 8 plus 5. And the only way to make that total exactly 8 is to have the other 2 digits be 1 and 2. So we can eliminate 1 and 2 from here. And we can also eliminate 5 and 8 from here, and so the only remaining way to make a sum of 9 in these two cells is for them to be 3 and 6, which puts a 2 right there. And the remaining 2 digits in the column are going to be 4 and 7. So now our 8, we've used one of our high digits, 7, so our remaining high digits, like I just talked about up here, are going to be 5 and 6. So it's either 2 and 6 or 3 and 5. And that's not too restricted yet, so we're just going to hang on to that for now. Next observation, the 5 eliminates 5 from those cells, so this is going to be 5. This can't be 5, so that can't be a 1. This 10 is actually more limited than it looks like it is, because it can't be 1 plus 9, and it can't be 2 plus 8, because we have 1 and 2 used in the region already. And it also can't be 4 plus 6, because we've used a 6 in this fresh 6-8 pair. So the only way to make 10 here is 3 plus 7. And that gives us a 3 in the row. 3 has to be in one of these two cells. That means that can't be a 3. So that's a 1 and a 6. That's 3. That guy can't be a 1. Now what's this going to be? It's got to be 6, 7, 8, or 9 again. Can't be 8 because it in fact sees 2 8s. So it's a 6, a 7, or a 9. Now if it's a 6, the only way we can make a sum of 6 would be 1 and 5 or 2 and 4, and we've used way too many of our low digits here for that to work, so it's definitely not going to be a 6. This is either a 7 plus 4 to make a sum of 11 in the cage, or a 9 plus 2. Notice too that this 6, this is either 2 plus 4 or 4 plus 2, so this is not a 5. So that gives us, interestingly, a 2-4 pair in the row, so we can eliminate 2 from these cells. This is now a 3-5 pair. So let's look at our two possibilities. It's either 7 is 2 plus 4 plus 1. That should be fine. Or it's 9. 9 is 2 plus 4, which makes 6, plus 3, which is not okay because we've used a 3 in the row. So this must be a 7. This must be a 1. To finish the 11 cage, we need a 4 there. That's going to make this a 2 and a 4. That's now a 1 and a 2 and a 1. And now to do a sum of 7 in 2 cells here, we need a 2 and a 5, because we've already used the possibility of 1 and 6 and 3 and 4 with the digits we already have in the column. So that means in this 8 cage, we're either going 2 plus 6 or 5 plus 3. We'll leave that for now. To finish this row, we need a 6 and a 9, and now we've used a 6, so that has to be 3 and 5 with a 2 right there. And because we've used a 5, this 14 sum can no longer be 5 and 9, so that must be 6 plus 8, which resolves because we have a 6 in column 6. Now we need 1, 4, and 8 to finish this region off, and that doesn't resolve yet. We need... that can't be an 8. We need 2, 5, 6, and 8 here. The 5 and 6 have to go there and there. The 2 and 8 are going to go in those cells. And my last digit in this row must be a 9. That resolves this 8-9 pair. Here I need a 2, a 7, and an 8 to finish the region. 8 can't go in those cells because there are 8s in these columns. So that's going to be my 8. The 2 resolves this into a 7, and then that is going to be my 2. Now to finish this column, I need a 3 and a 4. To finish this column, I need a 5, a 7, and a 9. The 9 can't go in those cells because of the 9 right there. So that's my 9. That's my 5, and that's my 7. And my last digit in this region is a 3. Now I need a 5 and 7 in this region, like that. That resolves my 4 and 7, gives me a 1 right here. This 3, 5 by value is now going to get resolved because this is a 9, so it's either 3 plus 6 or 5 plus 4. And it can't be 5 plus 4 because there's a 4 in the region, so it's 3 plus 6, and that's a 5. That makes this a 7, and it also makes this an 8 because of the 6 we have below it. Now these cells are going to contain 1, 2, and 9, and we can finish those now. We need a 4 and a 9 to finish this region. Up here to finish this row, we're definitely going to need a 4, and we also need a 7. And to finish this column, our last digit's going to be an 8. Here we need a 1 and a 5. We need a 2 and a 9 to finish this row. That's going to be an 8 now, which resolves this 4, 8. And our last trio of digits are 1, 4, and 6. And they go in just like that. And that is how you solve Philip Newman's deadly math. Hope you guys enjoyed that one. The link to solve it yourself is in the description below this video. and I will see you again in 3 days.